All right, welcome back. Let's begin. To my Twitch viewers, thanks for joining with me this evening. It's a pleasure to have you back with me, and I really appreciate you spending some time with me again, which gives me confidence that I must be doing something right for you to keep checking me out. For my YouTube viewers, I appreciate you checking out the video, and if you've stuck with me this long, stuck with us this long, thank you. I really appreciate it. This has been fun, and we still have a long way to go. So in the last stream, the last video, we created the ECRs, ECNs to log some of the changes we want to make, such as the extended ground copper pores around the power supplies, add more test points, and those type of things. And we started adding things to the board, the schematic, and started updating the layout and making some changes there. I would like to add a couple more test points if possible, if I have the room for it. I think there's room. So let's flip over to the KiCad PCB. So yeah, the KiCad kicked out these resistors from their place. It's fine. I'm not worried about that. We'll fix this later. These are for the optos. Things have to be moved around anyway because we will move these connectors out by 1.5 to 2 millimeters so they clear the enclosure walls, just to make it a little bit easier to connect and disconnect the pluggables. So I'm not worried about that right now. I want to see if we have room to weasel in more test points. There's plenty of board space. Idealistically, I like to keep things as relatively close to where they're accessed as possible. Like the micro stepping. So would need 3 more test points for the micro step. We might be able to stick them in here. I would like to add 2 test points for the PWM and the tax signals, and then another test point over here for the fault detection. So let's see about throwing in those guys real quick. Now, I had mentioned about adding more schematic sheets, and I'll get to that. They're going to be for 2 separate things, not for schematic capture, but for additional things. So one of them is I want to put together like a test point index. You could go to get the test point number and what circuit, what function it serves. That way you're not having to flip through schematic sheets. It's something I started doing at work and on my other projects. Just a quick, at a glance, this test point is for this. This is what it serves. That way you're not, like I said, not flipping through the sheet trying to figure out what test point 27 goes to. You'll have an index right off the bat. And then another schematic sheet, basically just to serve as a change log. I know, change logs are common with software, but I don't see any reason not to use them for hardware designs, to actually have an actual, a log of changes, like revision 2, this is what we added or changed. This was the ECN that we changed it off of. Because a lot of times you'll see schematic sheets and you'll see these little blocks in here, and they try to cram as much crap as possible in there. And I think that's dumb. I think it really makes it difficult to read and to understand the intention or what was going on. So I figure a whole sheet dedicated to just change logs. That way everything's more spelled out. And if you ever have to refer to this design in the future. So let's say you've got a 10-year plan for this project, for this board. You want to be able to make sure you push this thing out for 10 years. And let's say 5 years down the road, you have to make a change due to an obsolete part. Your company's grown. You've got another engineer working on it. They pick it up. That way there's a nice, clear, clean log of all your changes, why they were made, what they were attached to. That way nobody's left guessing. Because just like with software that's not properly noted without proper documentation, it becomes confusing when multiple hands enter the cookie jar and everybody tries to work off of that. So we are going to, there we go again. I was just using Altium earlier today, so I'm used to doing other packages. So we're going to pull that out. Let us get our net labels in there. And then step fault. Grab that guy. All right. So we have our step fault. Microstep 0, 1, and 2. This way we could get in here and get more test points and, probe around the stepper controller, which is probably more of what we're really looking to do. Since this is the core of the project, it'd be dumb not to have test points for this guy. So I just want to get that all cleared up and organized properly. So let's get some of these guys in here. All right, let's throw the lines out. All right. So we want to underscore ms 0 microstep 0. Last one. Step 2. And STP FLT. Okay, so that'll take care of these guys. So let's go back to the PCB. Let tools update from the schematic. Update. Let's see how mad. Okay, good. It's not angry again. It didn't throw part. It didn't throw a fit with any other parts. I don't know why it did with those resistors. 0.635, 0.127. That's why I didn't move them yet, because I don't want to have to duplicate any of my work. I don't know why it moved them in the first place, but Altium's done things like that to me too. Okay. Now, yeah, we have a ton of real estate down here where we could put these guys. I mean, personally, I'd prefer them to stay up here by this stepper driver, because that would make the most logical sense. I could probably tuck a couple of them like right in here, 1 or 2. The temp sense, I could kind of weasel over here a little bit. I could kind of move some of these guys down a little bit, maybe fit a few more in here. Maybe we'll see, I'm pretty sure I've got enough room right in here to connect and disconnect the JST connector for this. The actual pluggable is not that big. And I think I've got more than enough room right there for it to fit in there. Because generally, once this thing's assembled, you're not really going to be connecting and disconnecting, all day long. So, well, yes, I would like to have all them. So I could also move these guys down here to keep them all together. But we did all that beautiful routing. But got to figure out what makes more sense. Because as far as the PWM tax signal, I can probably tuck those guys right up here. That wouldn't be a problem. You can always move the logo over a little bit. I mean, it's going to change anyway. Yeah, we'll stick test points where we can stick them. Let's see how these guys look down here, if there's enough room to pull 4 more. Because if there are... Again, I still like to stay around here. Stay as close as possible. What I could do... See, the problem with this guy is it'll actually serve as an antenna, and it could interject noise into the temp sense line. So I don't want to move that any further than I absolutely have to. And I don't want to interfere with anything here. I could kind of push it up a little more. So let us go to that interior trace. Let's go and get rid of these the trace I run for. Let's grab that. Let's see, let's go 55. 53. No, I don't like that. So 52. A little close, star 25, but that's fine. Trying to shorten the distance between here and where it's going to ultimately tie into. I could kind of move it over. We should, yeah. Put it back there. I don't want to risk running any of those ground pins. Ground vias. And what I'm going to do is I'm going to try to bring the trace up this way. Because I might be able to drop some of the... Yeah, okay. We might be able to do it that way. Get some of the micro stepping traces in here. Might be able to clean these guys up a little bit, tighten their pattern up. I just noticed I don't have things lined up right. What's kind of weird. All right. Well, that does that. So let's go ahead and let's get you. Okay, so let's go to the top. There we go. So, you know what, for the heck of it, let's just kind of shotgun these guys in here. No. All right. Instead of shotgun, we could use a candy sprinkle. Basically just candy sprinkle those guys in here. So if we tighten everything up, nudge a few things over to the right a little bit, we can route that one trace. All right, that's what we can do. Because I would definitely love to keep this stepper. So these test points, those designators can all go down there. All right. So if we kind of candy sprinkle this guy up just a little bit more. I don't like being too close. But if we Oh, okay. I see. That's kind of cool. Instead of being an absolute value based off of the XY of the board, it's a relative value based off the distance from the component. That can make a life a little bit easier. Huh. Okay. Learn something new there. Okay, that'll help. That'll help. So if I want to go in and fix it in the future. So what we can do with this trace kind of nudge it a little bit. Give us a little bit more clearance. We can get in here and grab this guy. Give ourselves a little bit more clearance on that one. So let's see what the 76 looks like. 76 looks fine. There you go again. All right. Looks like we're far enough away. 53. So all right. So get rid of that. Now let's first kind of give you 81. Kind of push you in there a little bit. There we go. 76. And we'll go with that one's Y value. Nope. 46. I knew something was off with that guy. Yeah, we'll clean that up a little bit. Because what we might be able to do is kind of... Well, you know what? Let's do that. Nope. All right. That works. That gets that away from there. Okay. Here we go. Let's fix this trace. And 81. Nope. There we go. Now, 81, 76. All right. Now it's time for the math. Actually, 81, 76, 5. So it should be 81 plus 5. I know it's going to be 86. 86 plus 5. Yeah. 91 should be 96. And 96. Oh, look at that. All right, so what we can do is we can take that guy, kind of get a little further away. Could even kind of put him here. Kind of clean up that zone a little bit. That's fine. All right. And again, these are test points. They should be far enough away from each other. That clipping on a scope probe or something should be relatively easy. Or a multimeter with the little grabbers. Through my testing, I had no problems grabbing onto any of them. 2.6. Oh, I like this. Okay. I do like that. Oops. That's kind of neat. I do like that. So if we really wanted to push our lines and stuff, we could really do that. Okay. So micro step. Okay, step fault goes here. So I can, let's see, bottom, what's going on the bottom here? Could kind of pull up and around. All right, so that's what I do. All right, there we go. 0 comes around, goes there. This will get more difficult, but that's fine. Let's try. All right. Now, Microsoft 1. You up. Let's get you out of there. Let's get you organized. Go. Then we can route micro step 0. There we go. So obviously we could have rearranged, had these backwards, but this works. Because again, you're just looking at pure logic ones or zeros on these. It's very rare that any kind of analog noise is going to affect that, especially when it's being driven by a microcontroller. Most of these test points, the majority of these test points won't cause a problem. The only one I actually worry about is the temp sense. But worst comes to worst, we could always kind of try to compensate for that, which is fine. All right, so that is the test points for these guys. So that actually worked out really well. They're close together, but that's fine because, like I said, we found that they work okay with all these guys being crammed together like that. So let's go back to the schematic. And actually, I think the stepper driver is already here. Mouse does not want to work today. All right, so let's grab pull that guy out. And so now we're gonna throw. Boink. Okay, so it's fan, tack, and that is fan for WM. All right, so that throws those test points in. Now, we're going to pull them in. Update those. Now we got these guys. And we're going to make it mad, but that's fine. Huh, look at that. Perfect chance to clean this up. Make everything more uniform. Yeah. That might change. All right. So we could probably put those guys side by side, or one over here, one over here. So let's see. PWM's over here. Tax over here. Or they can both go over here. Yeah, having them both over here would be better. Get away from that big ground port. All right. So 77.5 actually works. 3, 8, that's fine. And PWM and tack. Get rid of that dog leg in there. Go. Tack. There we go. So now we just got our all these additional test points, which is beautiful, very helpful. I think we're good on test points. We've got pretty much all the ones I think we could actually use that are actually useful. Because again, the motor you can kind of tack on here. We could throw a couple more to touch some of the other stuff on here, like the current sense, but I don't know if that's valuable to us in this context and what we're trying to accomplish. So if it becomes something down the road that people may want, may ask for, we'll deal with that as we go. So I notice we're already not at the edge of the board here with our connectors. So the silk screen right here kind of is a good rough guess, rough estimate. So we are away from the edge already. So let's... All right, so let's move the one that would be the easiest right here, which would be this guy. So we are... So I want to get us to the edge, at least with the silk screen overlay, and then the additional. So let's go to 110. Let's see what that does. All right, 110 puts us at the edge. On this side anyway. So 111.5 will push us past the wall on the enclosure, which should be more than sufficient. All right. We'll have to re-pour all grounds, but that's for all polygons and everything, but that's not a problem. So, yeah, that's fine there. And so, okay, now the USB is fine. I tested it. It plugs in just fine. And since that's realistically just for programming this guy, it's not like a debug header or anything. I'm not going to be too worried about that. Okay, so we're going to have to move a few things on the bottom here. So, all right. Okay, so let's get this guy in here. Okay. All right. It's like that guy went ahead and followed that over. Now, let's see. That resistor's a little close. So let's go to the bottom layer. Yeah, I don't like that at all. This guy's gonna have to move too. Ugh. All right. That's fine. So let's kind of... All right. Yeah, I was afraid I have to do this to route it. Kind of go this way. Don't know why I'm fixing that one, because when I move that TVS, it's going to mess with that. Okay. Track. There we go. Not like that matters. So that pushes, okay, so it's still fine. This guy's going to be the fun one to move. Make sure, let's see, tracks, vias. Zones. Let's get rid. No, I need the footprint. Don't need that. Don't need the... All right. Other items. All right, well, I guess I'll just have to deal with that when I get there. Via. All right. Should be fine there. All right. All right, let's not grab footprints now. Okay, let's clean up. No, I just want to drag you. There we go. You're fine. You're fine. Drop you down. There we go. There we are. Tools. All right. I know there was a way I was no. Okay. Okay. All right. I'm gonna have to probably move this via just a little bit over, get away from the edge. I don't like that. Okay, just fill those zones. All right, that works. All right, that works. Okay, so we're not smashing anything in here. That looks good. Yeah, I wanted to avoid having to buy a new stencils for it, but there's no way we're gonna have to. We're gonna be able to avoid buying new stencils. That's fine. So that moves these connectors out to the edge, and then the 1.5 millimeters over. So when it's in the enclosure, they'll at least fit right. It looks so much nicer. So let's take care of these guys. Other items, zones, footprints. No, let's zoom in so I can see. 10 millimeter puts us there. 10 minus 1.5. There we go. These guys are going to be fun having to fix these, but that's fine. Oh, maybe not. Maybe not. Maybe not. So let's worry about this guy first. So, top layer. We just bring this guy in a little closer. That solves that guy. We could move the text a little bit. Maybe we want to. And that'll help kind of unclutter it from here. So we'll take care of that in a minute. Let's first solve the core problem of getting all these guys tied together here. All right. Lovely. Lovely, lovely, lovely. All right. These really aren't that bad. Oh, that'll actually be fine. They're far enough away from the edge. I was really afraid these things were going to be a pain in the butt, but we could move them a little bit more if we wanted to. Let's see how 3 looks. Yeah, I don't like that. It's like right there. That should be more than fine. Just have to be mindful when soldering the through hole. And that's fine. That'll work. So let's go through and start fixing this guy. Right. Let's get rid of, let's not do footprints right now. Oh. Yeah. Delete that there. All right. All right. Route this. All right. Leaving these and putting new tracks down. Boom. Oh, hey now. Need you hanging out there. Let's try this. All right. That went a little smoother than I was anticipating, and that makes life a little bit better. All right. So now these we just does. Blah. Back. Okay. Is there a way to... All right. So let's just grab this guy and he goes here. Oh, 138. Connected. It's connected. 21 in, so that's fine. Okay. $8.5. This guy. Three. Mm. 27.5. Right. Come on. KiCad, just play nice. 2. And this guy. 2116. All right. Okay. So that actually was able to smash all those guys out there and move parts successfully. Yeah, I mean, while the clearance here is more than enough, I think it'll just be more of a thing to watch out when we do the through hole assembly. But since they're connected anyway, a solder bridge ain't gonna be a big deal. It just electrically, it's fine. As far as visual inspection goes, won't necessarily be IPC passable. So let's see here. 5. Yeah, we're gonna fix all this. Get rid of all. Make sure we don't grab anything else. And we'll do the other text as well. Clean up all the ground pores. Yeah. All right. All right. Push those guys a little bit. Now the other thing we really need to do is work on expanding these ground pores around the power supply chips and adding more vias. So let us grab this. I think it's considered another item. No. Is it a zone? Yes, it's a zone. So let's go ahead and all right, let's see what that looks like. Zones. Beautiful. Let's go ahead and bring that guy up here. Okay. All right. All right, okay. Yeah, it'd be dead copper over here anyway. So, grab VS. Let's just add some more vias. Now, it used to be back in the day, you used to be charged mainly for the number of vias you had, like per via. Now it's pretty much the via type. With if you've got blind vias, vias like that, that's where some of your charge nowadays for board manufacturing comes into play, is the type of vias rather than the number of vias. You got to remember, pretty much all this is automated. CNC machines doing all the work. They take your Gerber files, they plug the data into basically a CNC machine, and it does all the work with drilling and everything. So it's not like a human has to handle it anymore. All right. Let's see if we can sneak a via like right up in here. There we go. Okay, so a via, in the context of of PCB, so a via is basically just a pathway between one layer of the board to another layer of the board. So you've got different via types. So in a nutshell, what's called a through via is not terribly much different than like the through hole for like one of these guys, like a through hole pad for like a capacitor or something. A via is just basically a through hole via, like a 1 to, let's see, what are we? We're a 6 layer. So layer 1 to layer 6 via would be considered a through via. But vias can be manufactured in other types. So there's a blind via. So you could see, like, say if it's a 1 through 4. So we're punching from layer 1 to, or 1 to 3, a signal layer. So we're going from layer 1, which is your top copper, and we're going to, like, say layer 3, which is an internal signal layer, with a via that's called a blind via. You can see where it starts, but you can't see where it ends. And then there's called a buried via, which is, as it sounds, you don't even know what's in the board at all. So it could be between signal layer 2 and signal layer 3. You don't even know what's there on the board. Due to the manufacturing processes of PCBs, sometimes they have to go through multiple lamination steps, basically where humans do have to get involved. And basically they have to, reorient the sheet, the PCB, to properly drill, punch the holes, and insert the vias, get them installed layer by layer. Whereas a regular through hole via, like 1 through 6 in this case, they're the cheapest and the easiest to throw in, because it's basically all done in one shot, one drilling and installation process. And then you've got things called micro vias, which, as the name implies, they're very small vias. Yeah, they're for like what's called HDI, high density interconnect. So the PCBs that make up your smartphone, your smartwatches, all your high-end wearables and portable tech, typically will use what's called micro vias. Basically, they'll use lasers to drill the holes, and these guys can get downright small. Via and pad design. So I'll probably use that in other contexts, maybe in other videos that I do. Who knows how the future is going to shake out for this channel and what I want to do. I do want to do more. But yeah, so that's what a via is. It's just basically, it's a pathway. You're going from layer 1 to layer 4 via this channel. That's basically the way you got to look at it. That's all it is, just an interconnect. So you know what? Let's go ahead and grab this guy. Let's go ahead and finish pulling him over to fully encapsulate all of those. Full zones. That way we get the copper pour. All right. All right. You can probably pull that guy out of there. Actually, just kind of over here. And honestly, the more pathways to signal ground you have, the better you are. It's almost more important than your pathways to your positive supply, to your 3v3 in this case. We got plenty here, but for example, your ground pathway, because this was called your return. So typically your noise is going to be sent down through your return. So sometimes your grounding is far more important than your supply. Your return path is far more important than your supply. So as a general rule, sometimes, you don't want it to look like a piece of minced meat, but at the same time, you want to make sure you have good return paths and everything else. So let's grab this guy. Let's do the same. Go and bring it over here. Kind of pull it down here a little bit. And we're going to kind of pull this guy up. All right. We're going to edit. We're going to re-pour it. All right. Beautiful. So let's see if we can throw a via up here. Let's see if we can grab this guy and yeah, that works. Puts a ground via right there. Throw some more ground vias in here. We need that guy. So a little bit of a better grid here. Is this? Get rid of those guys. Rather than fighting it. All right. So that guy's good. We can probably throw a couple more vias in here. Never hurts. Yeah. So just keep that in mind moving forward. That nowadays you pay more for the via type rather than the number of vias. Yeah. As you keep in mind too, because if you ever do anything with RF, and you need to do something like a via fence and to properly ground the via fence around like an RF signal, your board will look like a piece of Swiss cheese. But yeah, the project I'm working on, we had literally made a board that looked like, a little section of Swiss cheese because the RF signals on it. And yeah, it didn't really cost us any more for all these hundreds of vias that were there for that via fence, because they were just through hole vias, standard size through hole vias. So we're on the bottom layer. What we're going to do is we're going to throw in a big copper pour underneath that'll get grabbed into these vias, and we might just throw a couple additional ones up in here. So we're on the bottom layer. Going to, I think it was this one, a filled zone, or was it this one? Okay, yeah. Okay, it's going to be ground. All right, so we're going to come all the way up here. And this will just add more thermal mass to help pull heat away from the power supply ICs, the two switching regulators. Oh, I didn't catch it. Oh, you booger. See if we can get that ground. Okay. Must have not clicked on it exactly. We can always redefine the border. Let's not worry about it too much. I can clean it up. We can always clean it up. I want to worry more about getting it actually connected, because it didn't connect that time. There we go. There we go. All right. Edit. We're going to fill all zones. Oh, that's just beautiful. That's just beautiful. Pull this guy out a little bit. All right. Pull him out a little bit. All right. Edit. Yeah. There we go. So because of that, we're going to go ahead and just kind of put a couple more vias in there. At this point, this board's already looking like a lot of Swiss cheese, so I'm not terribly worried about how good ties. All right. All right. Oh yeah. So this should give us plenty of thermal mass to help just pull the heat out of this guy, out of these two chips, just to make sure. Again, I'm not anticipating that in actual use that any of these guys are going to be delivering their full 2 amps of current. So they shouldn't be generating that much heat at all. The ESP32 and the ancillary subsystems don't really pull that much. Again, because the stepper motor, the stepper driver, all its power is delivered directly from the main DC input, 24 volts. So that should cover all the board changes right now. Now what we're going to do is... All right, let's run the DRC. Whole clearance. I'll play through whole CN5. All right. Oh, okay. Yeah. Yeah. Yep. Okay, so those unconnected, blah, 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 blah. Because we didn't actually mess with any of that. I think it's just courtyards overlap. Yep. These I expect. Silk screen. So this is just complaining because the silk screen overlays, it goes over the pass of the board. Yeah, so this is just a design rule check. So we predefine parameters for the board that we want it to fit within, and then we run a tool to test everything against those predefined parameters, like trace width, distance between parts, and things like that. And this is just showing all these errors and these warnings. And I expect these like courtyards overlap, which is perfectly acceptable. So a courtyard is generally just an area that you want to use to help space components. It's sometimes there's multiple courtyards defined for a component based on the desired density of the placement. So HDI boards, obviously you want to be able to shove components closer and closer together. So the different courtyards can be used to do that, to help show like your safe placement boundaries. KiCad obviously throws up errors when you're courtyard. So that's what these pink things are. It's just the courtyards overlapping. I don't care. Silk screen clip by edge, that was expected. So here's the board edge. The silk screen of this part would be extending past it. I don't care. I expected that. And then it's complaining about some other things that we have no control over, like this hole and the tolerances and everything being too close to pads. And then these pads, these footprint pads being too close, there's nothing we can do about it. So Altium, you can tell it to ignore footprints in a pad, so it just won't even error on these kind of things. So all this is looking fine. Oops, I want to clear the rules. Delete all markers, close. All right. So I was mainly looking for air wires, not connected, direct ground, like direct shorts and like any of the traces, but none of that looks like none of that came up. So it looks like we've got the majority of the board updated. We got the ground pour. We've got these guys moved. We got all the test points added. Got all that cleaned up. Yeah, sometimes two or more board spins aren't uncommon for a new design. I've seen some people do up to 5 board spins before they get it right. And I've worked on projects where they just so many board revisions because so many things weren't thought of, so many things were missed. So as we kind of go through, we'll think of a few more if there's anything else we want to add. There's still some real estate we want to add any more test points if we really think we need them, but I don't think we will. But we could. We got some board real estate down here, got some up here, but I don't think we're going to have to. I think we've got pretty much all the primary signals covered that we absolutely want to get covered. So I think we'll just leave level enough alone. So next time what we'll do is we'll go through and we'll create the test point index. We'll add the changelog information. Maybe we'll start the review process on all the updates, dump all the Gerber files. Generate them all, I should mean. We'll have to update the BOM. We'll have to basically get the BOM updated for all the new test points. Double check their Gerber files. Get everything ready. So maybe next week or something we can order the PCBs and the stencils so we can build round 2, version 2. But I want to make sure before we get too far ahead that nothing else needs to be changed or updated before we do spin this board. So I just want to kind of, take a day or two to catch up on some of, like I said, the change log, the test point log, because we might catch things we missed or things we want to add. So that's what we'll do in the next video stream, which will be Friday. So I thank you guys for hanging out with me this evening, and I really appreciate it, especially given the weather that's been going on. For my viewers on YouTube, glad to see if you live in one of those states that get hit pretty bad. I know there are a lot of people out of power, so I feel bad for you, and I'm glad to see, that you made it through and you're safe. But I will catch you guys Friday. Have a good rest of your evening.